Okay, so if you remember from when we were proving triangles congruent, when triangles were congruent, we would end up with 3 congruent sides, and then we had, I'm getting kind of small here, all the congruent angles. But if you remember, we didn't end up having to prove all 6 of those pieces in order to prove the triangles were congruent. We proved them by side, angle, side. We proved them by angle, side, angle. Losing my mind here. Hypotenuse, leg, and side, side, side. Okay. And angle, angle, side. There we go. Okay, so just like proving triangles similar, you don't have to prove all 3 all 3 angles are congruent and that all 3 pairs of sides are proportional. When you prove triangles similar, we can prove them by side, side, side similarity, side, angle, side similarity, and angle, angle similarity. And the reason why we don't have to have angle, angle, angle is because we know from previous chapters that if you know 2 of the angles, you know the 3rd one. Okay, so here are the methods that we are going to be using. Okay, so for side, 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 it's exactly like you would think it would be. You have to prove all 3 pairs of sides are similar. Be careful that your figure is not flipped or rotated or anything like that. So I'm actually looking at 3 is the smallest of this triangle, 9 is the smallest of this triangle. So 3 to 9, 7 is in the middle, 21 is in between these 2 as well. So 7 over 21, that should equal 8 over 24. And I do get a ratio of 1/3, so the sides are proportional. So therefore the triangles are congruent by side, side, side. If we look at side, angle, side, just like incongruency, that angle has to be included, in other words, has to be in between the 2 sides. Okay, so, oopsie, sorry. So I know that the 2 angles are congruent. I just need to check to see if these sides are proportional. So 8 is to 4. That should be equal to 4 is to 2. And it reduces to 2 over 1. The sides are proportional. Therefore, you can prove the triangle's congruent by side, angle, side. Okay, let's go through a few examples. Let's prove, gosh dang it, sorry. Let's prove the triangles are similar. If so, write a similarity statement. Okay, this one, it incorporates that reflexive property. So in the triangles, let's make this A, B, C, D, and E. So in the triangles, this small triangle shares the angle of this bigger triangle, so they both have that angle, so that is the congruent included angle. So now we gotta check and see if the sides are proportional. The biggest error here is that if I take the left side of the small triangle and I compare it to the left side of the big triangle, this is the entire left side of the big triangle, which would give you a 15. That should be proportional with the right side of the small one over the entire side as well, which would give me 10. So if I check by my means and extremes, or I can reduce each of the ratios, I end up with 120 equals 120. They are proportional, so yes, these two triangles are similar. So I can say that triangle ABD is similar to triangle, they both have A. This would be the corresponding one, and E. Okay, we have two more examples. Okay, example 2. Kind of a weirder figure here. Okay, so we have a right angle and a right angle. This is 55 degrees and that is 35 degrees. M, N, P, and Q. So, the first thing I would do is find the missing angles. So if this is 90 and this is 55, these two angles are complementary, which means that this has to be 35. Same thing with this one. This is a right angle, so these two have to be complementary, so that means this angle is 55 as well. So I have 35, 55, 90, 35, 55, 90. So yes, the triangles are similar by angle similarity. And it would be triangle, if I do MNP, is similar to triangle. M is a 35 degree angle, Q is the 35 degree angle, N is the 90, P is the 90, and then P in this first triangle is a 55, and the N is the 55 for that one. Last example, getting a little bit of algebra in here. Okay, so this relates to that first example I did. We're trying to prove that they are, actually, no, I am telling you that they are similar. Triangle ABD is similar to triangle ACE, so we have to find X. So in order to find X, we're going to set up our proportions. So the left side of the smaller one is 12. The left side of the bigger one, it is not 12x. Remember, in order to find that this is 10, we add these two. So we add these two. So x plus 12, that should equal the right side of the small over the entire side of the big, which would give me a 10. So I can either reduce this or not, means and extremes still, or cross multiplying. 120 equals 8 times all of that. So we have the distributive property. 120 equals 8x plus 96. Do our algebra and subtract, and you get 24 equals 8x. Divide both sides, and you get x to be 3. That is it.